Welcome to the 4.8 Notes Conjugate Roots Theorem. The conjugate root theorem is over here on the left. Essentially, it's pretty easy. It just says that complex or irrational roots must occur in pairs. Complex means it has an I, irrational means it has a square root. So essentially the rule is that if you have one that has a square root, the negative square root has to also be there. Same thing with an I. If you have an I, negative I, or that many I's, has to also be there. This means that they can only come in groups of two. Here's an example of why down here. If you were going to solve this problem right here, you'd have to take the square root of both sides. And when you take a square root, then you always have to have this plus or minus. Okay? And the reason why this works for square roots and i's is because i's only exist because of the square root of a negative number. So this I comes from the square root of negative 9 instead of just 9. And again, on the second one, the only reason why the square root of 10 was even an answer is because I had to do the square root to get rid of the squared. And again, anytime you do that, it has to have this plus minus. The reason why this doesn't have to happen with any other number is because it might not have come from a square root at one point. But these two things specifically only come from square roots, and when we do the square roots, we have to do that plus or minus thing. Okay, so one thing about this section is it's going to be a little bit like 4.7 at the end, where it gives you one of the roots, and you just have to use it. And this is just kind of my reminder that roots are the same thing as zeros or solutions. So whatever root it tells you works, you're going to put that in the corner. So whatever root it tells you, you're going to put that in the corner. And then you're going to put your coefficients. Every time you do this, go ahead and stop to make sure that it goes 3, 2, x to the power of 1, none, so that you aren't missing a zero placeholder. Draw a line underneath and drop the first number down. Every number that goes down there gets multiplied by the number in the box. 1 times 3 is 3. And then you add these two together, that gives me 0. 0 times 3 is 0. 25 plus 0 is 25. 25 times 3 is 75. And negative 75 plus 75 is 0. Now that number has to be 0, otherwise you've made a mistake. And then I have to go through and add my x's back in there. The first one is always your constant. And then as you move to the left, you add powers of x. So that one's x, this one's x squared. Basically, that means I have 1x squared plus 25. And I need to find the remaining roots. Sorry about that. By solving this equals 0. So I'm going to get x squared by itself by subtracting 25 to the other side. And then I take the square root on both sides. And whenever I do that square root, my first thought should be, I need a plus and minus. Now, the square root of 25 is 5. The square root of negative 25 is 5i. That gives me the last two zeros because this one plus the one it already gave me is 3 zeros, and I had x to the power of 3. Alright, second problem. We know that x equals 4 is a root this time, so that's what's going to go in the corner of my synthetic division. And my coefficients, first of all, check for a zero placeholder. X to the fourth, third, second, first, none. I'm good to go. So I just copy my coefficients down exactly as they are, not worrying about a zero placeholder because I already checked for it. Then you drop this first one down. And 1 times 4 is 4. Negative 7 plus 4 is negative 3. 4 times negative 3 is negative 12. 6 plus negative 12 is negative 6. Negative 6 times 4 is negative 24. 42 plus negative 24 is positive 18. And 4 times 10 is 40. 4 times 8 is 32. 40 and 32 makes 72. So my remainder is 0 as it should be. And then I leave the 18 alone and I start adding powers of x. X squared, x cubed. So I basically have x cubed minus 3x squared minus 6x plus 18. I'm going to split it down the middle because there's 4 things, which means I have to use grouping. And on the left 2, I can take out an x squared, leaving me with x minus 3. On the right side, my greatest common factor is negative 6. Just make sure that if this is negative, you keep that negative out front, leaving me with x minus 3. And x minus 3 matches, meaning I've got that. And then my outside pieces were x squared and negative 6. So that's my other parentheses. Now I need to set each of these equal to 0 so that I can find the rest of them, just like I did up here at the top with the x squared plus 25. If I wanted to solve this first one equals 0, I would just add the 3 to the other side, and 0 plus 3 would be 3. If I do the same thing on the other one, x squared would equal 6. But I don't want x squared, I want x, so I have to take the square root. And whenever I do the square root, I've got to have my plus or minus. And then there actually is not a square root of 6. So I'm just going to write it as the square root of 6. And that's it. Alright, we've got one more of this style, and then we'll talk about how to write the equation. So, x equals negative 2 is my root. So I put it in the corner of my synthetic division. I double check for 3, 2, 1, none. I don't have any 0 placeholders. And I drop the first number down. 1 times negative 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is 6. Negative 2 plus 6 is 4. Negative 2 times 4 is negative 8. Negative 8 plus negative 4 is negative 12. Negative 12 times negative 2 is 24. Negative 12 times negative 2 is 24, and that adds to 0. Perfect. Then I go through and I have to add in my x and my x squared and x cubed. So negative 12 stays the same. 4 gets an x, 3 gets an x squared, and the 1 gets an x cubed. So I have 1x cubed minus 3x squared plus 4x minus 12. There are 4 things again, so I have to split it up in the middle. I can take an x squared out of the first 2, leaving me with x minus 3. And I can take out 4 from the next 2, leaving me with x minus 3. X minus 3 matches between the two of them, so that's your first parentheses. And the other one is x squared plus 4. You want to set both of these equal to 0. Hopefully you know that the negative 3 is going to turn into positive 3 for your answer, just like it did right up here on the last one. And for the other one, you would subtract the 4. X squared equals 4. Sorry, negative 4. Take the square root. Square root of negative 4 is going to be plus or minus. Square root of 4 is 2, so the square root of negative 4 is 2i. Alright, let's practice writing equations using complex irrational roots. On this first one, this 4 shouldn't be there. It should just be negative 3i. So go ahead and erase that with me. Okay. The first thing you have to do if you have the zeros is write the factors. So I've now done 2 examples that had an example of a 0 at 3. Notice how that came from the factor x minus 3. Then, if negative 3i is a root, then also 3i must be a root, because they have to come together kind of like this 2i did. Okay, and there is a little bit of a shortcut I'm going to use, and then I'm going to explain the long way. This is going to be x minus 3i, x plus 3i, essentially. But when I go to multiply those two together, I'm basically thinking about where this I came from, and it came from a square root, which means I have to square the number in front of it, and it ends up being a plus sign next to x squared. Because, and I'm going to scroll away from this problem for a second, when it was plus, I had to subtract it to the other side, which is why it became, sorry, get the eraser out, there we go. It became negative 9 on the other side. But down here, when it was minus already, I had to add it to the other side, so it became positive 10. And you can do the square root of a positive without an I, but whenever you get the plus, it turns into a negative on the other side. So this actually right here, this is going to be the same thing as this, because you got your 3i and negative 3i. So we're really just trying to take it back to this, which is less of an exact step and more of us thinking backwards. If 3i and negative 3i are my answers, I had to have done the square root of negative 9 to get them, because the square root of 9 is 3 and the negative makes it an I. So it would have been x squared plus 9 in the factor. And then I just multiply these two things together. That's going to be x cubed, negative 3x squared, 9x, and negative 27. Notice how both terms in the first one multiplied by both terms of the second one. And that's my answer right there. There's no like terms to add together on this one. Okay, let's try this with one more. I'm going to leave that one up there too, so you can kind of compare. First of all, if negative square root of 3 is an answer, so is the square root of 3. If 2 is a 0, x minus 2 is its factor. And if I've got the square root of 3 as my answer, that means at some point in solving, x squared equaled 3. Because I would have had to square root both sides, and that's how I would have gotten the square root of 3. And if that's true, then I just subtract that 3 back to the other side to get this. Okay, so the factor would be x squared minus 3. Again, just like I talked about over here, if it was originally x squared plus, it ends up subtracting and turning into an I because of the negative. If it was a negative already, it ends up adding to the other side, leaving you with the square root of a positive number, so it doesn't need an I. So x squared plus ends up turning into an I, x squared minus doesn't. And I could have done that on the last one as well. I could have said, oh, if I've got 3i and negative 3i, then x squared has to equal negative 9, because the square root of negative 9 is 3i. And then you would add that 9 to the other side, and that's how I could have also gotten this one. Okay. Then for this last one, I need to go ahead and multiply it out. X times x squared is x cubed. Negative 2 times x squared is negative 2x squared. Then I need to multiply both of them by the negative 3. X times negative 3 is negative 3x. And negative 2 times negative 3 is positive 6. And that's my answer. In order to understand the two parentheses that have the x squared, you really have to understand how they solve first. So if you haven't done that part and practiced it often enough, that part's probably not going to make much sense.